Yeah, good day everyone. Let's look at another example under logic expression. Now, in the previous videos, we explained some rules that is guiding this logic expression and how to simplify them. So we're going to be taking another example. Now, the question says simplify the following logic expression using Boolean algebra. Now, this is it. To simplify this guy. So we're going to be making use of our laws to simplify it. Okay. So I guess the first thing we're going to be doing is to, if you notice there's a here, there is a here. So we can also write this to be a in brackets b plus b plus c. Then plus b, sorry, this is the solution, we're not solving. Plus what? C. So this is one way of solving it. You can also notice that this and this are also the same. There are tons of ways of solving this. Many ways. Let's finish with this method. Now we can remove the brackets now. And when we do that, we have that a b plus b plus c, then b plus, okay, b times b plus c. This plus this will definitely give us what? B. Remember when we said a plus a will give us a. The same thing as a times a will also give us what? A. So as long as they're like terms and they are adding or multiplying, we just have to collect one. So this plus c plus b plus c. These are like terms. So we can also write this to be b plus c in brackets. You have a plus b. This and this are the same. If you collect them as one and bring them out, so let's do what's a and what's b. Let's do what's a and b. Okay. Now from here you can open bracket and you have b times a. You are having a, b. Always try to arrange them in the alphabetical order. B times b. B times b is also going to be b. Something as a times a. Well, let me store it like this for clarity's sake. Now c times a, c times b. This will give us what? B. Okay. And what else can I add in again? Go. So we're going to be left with a of b plus a c and what? b c. Right? Now b is here, b is here. So we can write this to be a b, taking this one, plus a c. Now these two plus b plus what? b c. B is here, b is here. We can factor out b, and we're left with what? 1 plus what? C. A, C, A, B. Right? Now, continuing from there, we're going to be having anything plus 1 is going to be 1. So A plus 1, B plus 1, C, even C bar plus 1 will still give you what? 1. So they can be many alphabet, but so long they are adding to 1, not multiplying. They are adding themselves to 1. Everything there will totally become what? 1. So in this case, the whole of this is now what? 1. So we're going to be having A, B plus A, C plus what? B times what? 1. And anything times 1 is still going to remain that thing. So we're going to be left with A, B plus A, C plus what? B. Remember this was 1, this thing. With the 1 was 1 plus C. That gave us 1. Now, B is here, B is here. We can still factor out. We have A, we have B outside. We're having A plus 1. Then this guy. Now this is your B and your B here. So I brought the two of them out and I left it what? A and then 1. The same thing also happened here. A is adding itself to 1, so everything is going to become 1. So I left it what? B times 1 plus what? A C. This is going to give us what? B. So having B plus what? AC. If you want to write this to be what? AC plus what? B. So that's the answer to this question. AC plus what? B. Now we'll be going through another example. Okay. So this is the second example. Now the question says draw the simplest possible logic diagram that implements the same output of the logic diagram shown below. Wow. Okay. So now we're going to be seeing the application of our of us reducing our logic diagram. All this while we'll just be reducing it in terms of its logic expression. But you will see how we will reduce this diagram to a simple diagram. Now, the idea here is to, first of all, get what our output is going to be. When we get it, we use that our logic expression and we reduce it to its lowest form. So, looking at this, you can say that at this point, we want to get what our output will be. So at this point, we know that here is going to be what? A bar due to this inverter here. This is a NOR gate. This is going to be A plus B or what? Bar. Here is going to be B bar. This is another NOR gate. Here is going to be B plus C or bar. For this one, this is a NOR gate, which is what? When you add these two, you bar all of them due to this NOT here. So beware of this. So this is different from this. Now this is a what? A OR gate, an OR gate. So we're going to be adding the two together and we have A bar plus A plus B OR bar. This is A plus B OR bar. We are adding it to what? A bar. How this one is telling us now. The same thing also happen here. We'll be adding our B bar to our B plus C OR bar. Okay, now this is now a NAND gate. A NAND gate. So what we're going to be having here is we'll be multiplying these two results and then inverting all of them. We're getting the inverse of all of them or the complement of all of them. So let us go. This one is A bar plus B plus A plus B or bar multiplied to B bar plus B plus C or bar. We have multiplied the two. Now due to this not here, we're going to be complementing all of them. I didn't break the knot. It's different. So if this is different from when it's all joined, they're not the same thing. So in this case, it is all of that is what? Bar, because we're multiplying the two of them and then buying the whole result. So this is our output. So our aim now is to reduce this to its what? Lowest form. Now, this is where we start solving. Now, given that A bar plus A plus B all bar multiplied by our B bar plus B plus C all bar. All right, to reduce this stuff. Okay, now the first thing we'll be doing here will be definitely it will be using De Morgan's law. Now, for us to split these two brackets into two, De Morgan says that if you're having multiple here and you are complementing everything, if you are to separate the two of them, this multiple will change to what? Plus. So this is his second rule. So we're going to be having A bar plus A bar, okay, A plus B all bar plus B bar plus B plus C all bar. So for us to split this this complement that we have on the bar we have on top, the sign will change. Now, moving over to the next one, we can also split again for these two. When we do that, we have a bar bar. We want to split this in between them. A bar bar plus, no, not going to be plus again. It's not going to be what? Multiplied. We're not going to be multiplying times our a plus b bar bar. A plus b what? Bar bar. Now, moving over to the next one, the same thing will also occur here. B bar bar times b plus c bar bar. So for us to split the complements of the bar, our sign will do what? Change. Now, the issue is now our b plus c bar bar. What does this bar bar mean? What does this bar bar mean? Now, bar bar will cancel out itself. So when you are having, let's say, a bar bar, it's equivalent to what? A. This bar will cancel out this bar. So this and this are the same. A, this is the values of A. A bar will be 1, 0. A double bar will then be 0, 1. What this one is not. So when you compare this, you see they are the same. So the idea is that when you see your double bar, everything will the bar sign will cancel off, will go off. So that also goes for this our A plus B. So with that being said, let's continue solving. So from here, we're going to be having A times A plus B plus B times B plus what? C. Yeah, man. So we have gotten to this level. Now we can go further to open the bracket. When we do that, we'll be having this times this. Since that I like them, we'll just collect 1. This times this, we'll be having what? Moving over to this guy. This times this, they like them, so we'll collect 1. Now this times this will be giving us what? 6. Okay. Now remember our law that says, let me not go there. Let me just do factorize. Now this and this are having what? A. This and this are having what? B. So we can write this to be A in brackets 1 plus B. Right? When you take this out, you're left with this, right? Now plus B brackets 1 plus C. Right? Now I will say that anything that is adding itself to 1 will definitely give us 1. So I left with what? A times 1 plus B times 1. At the end of the day, you're left with what? A plus what? B. So the whole of this is simply just this. If you simplify, that's the advantage of you simplifying. So as you see now, this is just a OR gate. We're just going to be making an OR gate. So the answer to this question, draw the simplest possible logic diagram. So this is just going to be A, B. So as you can see now, what this is telling us is that the output that this will give you, this is going to be giving you A plus what? B. So the output that this is whatever this is going to be giving as output, that's also what this one will give us as what? Output. Now, how do we prove this? How do we know this is true? Is it compulsory that we have to implement it with our circuits and everything for us to know it is true? We can only use the truth table. If we are able to do the truth table of this and get its output and compare it to that of this, we'll notice that they're going to be what? The same thing. So I'll be doing that now. So now let's check whether this is equal to this using our truth table. Now we have this to be what? And we're going to be needing A, B, and what? C. Those are the 3 variables that we have here. the three Boolean variables that we have here. Okay, so let us our truth table is going to be having 8 different possible combinations. I remember how we got that from this formula. So we're having 3 variables here. So if you include 3 here, we're going to be having 8. So we're going to be counting from 0. So this is 0, 1, 2, 3, 4, 5, 6, 7. Asking why it not stop at 8. This is 1, 2, 3, 4, 5, 6, 7, 8. We're having 8 different combinations, but we are starting from 0 to count. So we're going to be ending at what? 7. So, like I said, we are going to be having what? 8 different combination, and each of these combination, this is it. So we're not counting from 1, we're counting from 0. So meaning that here is going to be ending with what? 7 and not 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 different combinations. And let us fill in the variables. We are going to be doing it in the column form. That is our 0, 1, 0, 1, yeah, 0, 1, 0, 1. For the next one, 2, 0, 2, 1, 2, 0, 2, 1, 2, 0, 2, 1. The next one, 4, 0, 4, 1, 4 zeros, 4 ones. So this method is quite faster and easier. So if we are having about 4 variables to work with, we're going to be having 16 different combinations. And for that next one, we're going to be having 8 zeros, 8 1. So the first one is 1 0 1 1 0 1 1, 2 zeros, 2 ones, 4 zeros, 4 ones. The next one, if there's another one in front of it, will be 8 zeros, 8 ones. So that's just the order it goes. Now we want to prove whether this is equal to this. That's our aim here. Looking at our expression, another thing again that we need to get for us to be able to get this is our a bar, b bar, and okay, we just need to get only a bar and b bar, just these two. So we need to get again. I don't need of us getting c bar since c is not bad on this o. So when we get a bar and our what? B bar. Now when we do that, we're going to be having our a bar. This is going to be 4 ones and 4 zeros. This one is going to be 2 ones, 2 zeros, 2 ones, 2 0. That is the opposite of what this guy is. Understand? Okay. Now the next thing we're going to be getting is a plus b and b plus c. That's for this guy and this guy. So we're going to be having a plus b. Let's do for a plus b first. Our a plus b is what? So we're having 0 plus 0, we have 0, 0 plus 0, we have 0, 0 plus 1, we have 1, 0 plus 1, we have 1, 1 plus 0, we have 1, 1 plus 0, we have 1, 1 plus 1, we have 1, 1 plus 1, we also have another what? 1. Now let's also do for b plus c. We go again. 0 plus 0, we have what? 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. 0 plus 0, 0. 1 plus 0 plus 1, we have 1. 1 plus 0, 1. 1 plus 1, 1. Right? Now, we're going to find the complement of these two. So we're trying to get, say our aim to get this and this. So we'll be finding the complement of those two. So we're going to be having a plus b all bar and what's b plus c all bar. Now, we're going to be negating everything that is here. So we're going to be having 2 ones and the rest are what? Zeros. Right? Now going over to this one, we'll be having 1 here. We have 3 zeros, another 1, and 3 zeros. Right? What this one is not, that's what we're getting here now. So we have gotten this. Now the next our next agenda is now to add this to this. So we're going to be adding this, whatever we got from here, towards A. we'll be having what? A bar plus what? A bar, A plus B or bar. This is our A plus B or bar, and this is our A bar here. So our aim is to what? Add the two of them. So when we do that, this is our A bar, and this is where our interest is in these two columns. So looking at the two of them, 1 plus 1, we have what? 1. 1 plus 1, we are having what? 1. 1 plus 0, we have 1. 1 plus 0, we are having another what? 1. 0 plus 1, 1. Is it 0 plus 1? I think this is it here. So 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0. So pardon me, this is what? 0. Remember, this is what we're looking at, this and what? This. So this plus this is this, this is this plus this is this. This plus this is also 0. This plus this is also what? 0. Move over to the next one. Our aim now is also to get this guy. So we're going to be having B bar plus B plus C, all bar. Okay. Now, that means our new interest. Our new interest is now what? This guy and each other person and this one. So okay. So 1 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 0, 0. Right? I move over to the next one. 1 plus 1, you have what? 1. 1 plus 0, you have what? 1. 0 plus 0, we have what? 0. And 0 plus another 0, we are having what? 0. Right? Okay. So we have succeeded in getting what this bracket is and what this other bracket is. Now we need to also multiply the two of them. We need to multiply the two brackets. So we're going to be adding these two. Though I cannot write the whole expression in this because I also need to do one more thing. So I'll just say, let's call this, can I just call this G and call this H? Allow me to just do that. So we're going to be having this G is representing this first bracket and the H representing the second one. So we're going to be, this is our H and this is our what? Our G. So we're going to be having G times what? H. Now I'm multiplying the two of them. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 0, 0. 0 times 1, 0 times 1, 0. 0 times 1, 0. 0, 0. Right? Okay. Now this is not demanding from us to negate the whole thing. So whatever we have got to now from multiplying G and H, I'm going to find the inverse. We have multiplied this and this and we got this. Now the complement of everything. So we're going to be having G times H all bar now. So we can now get what actually the total expression is going to be. So we're going to be having what? 0, 0. The rest is going to be 1, 1, 1, 1, 1, 1. Right? Now, remember what we said? We said the whole of this is equal to what? A plus B. Now, we have already gotten our what? Now, we have previously gotten our what? A plus B. And when we solved everything finished, this is what we got. Now, compare these two results. As you can see, they are giving us what? The same what? Answer. So that is the advantage of you simplifying your logic gate. They will still give you the same thing. The whole of this, as you can see now, is now giving us what? This. The whole of this is not giving us this. When we solved it, that's what we got. Now, our truth table is also telling us that it's also what? True. When we find the truth table of everything, you can compare the two of them. But you see, the truth table of this one was quite long. But this one is quite easy. This plus this, we know it, and we got our answer. So our truth table has told us that what we solved now is actually what's correct. So that's the advantage of you reducing your logic expression. So thank you for watching. That's all for this video. Subscribe if you haven't, and if the video was helpful, like, comment, share. Yeah, and be the best version of yourself. See you in the next video. Goodbye.